Hello, welcome to ALGO BYTE. Today I will be solving maximum depth of binary tree. Given a binary tree, find its maximum depth. The maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. A leaf is a node with no children. The longest path from root node down to the farthest leaf node here is 3, and it can be seen along this path of node 3, 20, and 7, or node 3, 20, and 15. Both are same, so you can return the same value, which is 3. While there are a couple of ways to solve this problem, namely iteratively using a stack or queue or recursively, I plan to do the latter, and I have the code laid out for the same, and I have an input tree, which is a very minimalistic tree in terms of the number of nodes, and I'm going to return an output of 3 because the depth or height, which are synonymous words, that they mean the same thing. I will be returning 3 because the depth or height is 3. As we can see here, node 2, 4, 3, there are 3 of those nodes, so we return 3. Now I have this sort of explanation of the recursion laid out here. So what happens is that every time we have a root node, like we do here, starting out 2, what we ask is the node null? Meaning, is it existent? If it is existent, we can run recursion on it. If it's not existent, then there is nothing to calculate in terms of the height. So once there is a node, what we do is have a recursion on the left subtree and right subtree. So it's pretty simple. Starting out, visit the node, and then visit the left subtree and call the maximum depth function on that left subtree, and do the same for the right subtree. Traverse the right subtree and call maximum depth of right subtree. And that's what I have drawn out here. So the plus ones in each of these computations is basically that every time we have a node, a root node or otherwise, we add 1 to our max of left or right, because that 1 accounts for that node that we're on currently. So starting out, we're on node 2, so we have a 1, and max of left and right, the math.max precisely in the code, that's a helper function to return the maximum of any 2 or more given values. So whichever of the 2 value is greater, it will return it. So I have 1 here for the root node 2, plus maximum of left and right subtree. So to find the left subtree, we have to call recursive function inside of the initial recursion. So for the left subtree, I have 1 because it accounts for the node 7 plus maximum of its children. Since it doesn't have children, it would be null. So it's basically asking what's the maximum of 0 and 0. It's just 0. So what you have out of this recursion of left subtree, and notice we have reached the leaf node, that is, this node 7 does not have any further children of its own. So what it does is this whole computation 1 plus max of null and null is that it gives a value of 1 to our original left variable. So it gives us our value for left. So we have a plus 1 that goes here. Oops. Plus 1, basically giving our needed input for the left value. And then once we have exhausted the left subtree, because our root now after having null null would be 0, it would go to the right subtree and run recursion on that. So on the right subtree, we encounter node 4. So we have a plus 1 for that, and we run maximum depth on its children. So we have a left child, as we can see, and we have a null for the right child because that child is non-existent. So this initial call for the node 4, and then another recursion on node 4's child, which is 8. So we have a plus 1 for the child 8, and maximum of its child we have to consider. But because node 8 doesn't have any children, it would be null and null again. So what's happening is this plus 1 gets valued here for the left. It adds value of 1 to this left here in the function prior to that. And then this computation here, which would be 1 plus maximum of 1 and 0. So maximum of 1 and 0 is 1. So it would add 1 plus 1. So essentially this computation is giving us a value of 2 to the right variable in our initial function. So now we have found our values needed to compute which of the left or right is greater. And it seems like the right subtree is greater because maximum of 1 comma 2, 2 would be greater. So we have 1 plus 2, which is 3. And that sure reflects the depth that we expected initially. So this is how the recursion works, and that's how you find the depth. I hope this makes sense. Now let's run the code on LeetCode. I have the same code as I had shown. And sure enough, it gives us an expected value of 3 for the tree here, which is similar to our tree in terms of the height. I'm going to submit this. And there you have it. I hope this makes sense. I try to clarify it as much as I can. But should you have any question, do post them to me. And I forgot to mention the time complexity is O of n and space complexity is O of log n. So should you have any question, let me know.